Alright, today I'll be going over LeetCode 271, string encode and decode. So we're going to design an algorithm to encode a list of strings to a single string, and the encoded string is then decoded back to the original list of strings. So here we're going to have to implement two methods, encode and decode. And for example 1, we see that the input array is going to contain the strings neat, code, love, you. And the output is also going to contain neat, code, love, you. So our task is essentially we're given a list of strings, and we're going to turn that list of strings into a singular string using the encode method. And then given that output singular string, we're going to use the decode method to turn that single string back into a list of strings that matches exactly the original input. Now the first part of the encode method is actually really easy, where we're just given a list of strings and we can iterate through that list of strings and turn it into a single string. And now someone's first thought may be to just iterate through these strings and just constantly append each string into a single string. However, that would create a jumble. For example, in example 1, if we went that approach, it would look like this, right? Now, this is an issue because when we need to decode this and turn it back into a list of strings, there's going to be no way for us to identify what is an individual word because it's all clumped together. So the approach we need to do is we need to use a special symbol. For example, in this case, I used a pound symbol called a delimiter, where this is essentially going to signal within the string where the stop and start of a word is. So if we use a delimiter like at the pound symbol, our output from encode is going to look something like this. And this is going to allow us to know where the start and end of a given word is when we decode it. Now, there is one problem with this part, where what if we have this symbol, this pound symbol, within a word? Then this solution is not going to work. So to work around this problem, where what if one of the words contains the delimiter, we are going to need to have another way of knowing how many times to iterate through the characters. So here's when we're going to take the length of each given word and then put it at the start of each word in delimiter. So in this case, this would look like 4 pound symbol neat. And then for this one, it's also going to look like 4 pound symbol code. And it's going to be 4 pound symbol love, and then 3 pound symbol you, where each number represents the amount of characters in each word. And the reason why we need to put the length is because when we are decoding this back into a list of strings, the number in front of each word in delimiter is going to let us know how many times to iterate through the characters and capture those characters into a word. Now, so once we have this essentially built up with the encode method, we're going to look at the decode method now. Now, this is where things are going to get slightly trickier, where we're going to instantiate a new array list that we're going to be returning, and then we're going to instantiate an I variable set to 0. And we're going to use a while loop to iterate through the input string. And essentially, this I variable that was set earlier is going to be used to locate a given segment, where, for example, a segment is going to be this. It's going to be the length of a word, the delimiter, and then the word itself. And then within the while loop, we see that we have this j variable that's going to be set to I. This j variable is going to be used to locate the delimiter within a given segment. So the j variable is going to be used to locate this pound symbol within this segment, for example. And now we're going to use another while loop in here. So while string.char at j does not equal pound symbol j++. So what this is doing is it's going to increment the j variable until it reaches this pound symbol, because we want j to find the delimiter. That's its job here. And the reason why we use a while loop instead of using just an if statement, because we can use an if statement and say if string.char at j does not equal pound j++. The issue with an if statement is that it's not going to account for lengths that are more than one digit. So using a while loop, it's going to allow us to keep on incrementing in the case that we have a length that is 2 digits or more, like 10, 12, 15, for example. And once we've incremented j to the end of the length, we're going to capture that length by setting it to a variable called length, and then we're going to call the method integer.valueof, and then we're going to take the substring of I, because right now I is at the start of a given segment, and then it's going to go from I to j, where j is at the end of the length. Oh, sorry, or where j is at the end of the delimiter, and then where that's not inclusive, where that's exclusive. And then after we have captured that length, we're going to find a new segment by doing j plus 1 plus length, where, for example, if right now I is at index 0, it's at 4, and j is at index 1, we can do 1 plus 1, that's going to be 2, and then 2 plus the length, which is 4, that's going to be 6. So right now we're going to have I equals index 6. So in this case, it's going to be 0, 1, 2, 3, 4, 5, 6. So now we're at index 6, and that's going to be the start of the new it's going to be the start of the new segment here. And then now we're going to call the method, and we're going to add this substring where we're going to take j plus 1 inclusive to I exclusive, because we know that j is at a given delimiter, and so we want to go one more index to capture the start of the given word. So we're going to do plus 1 there, j plus 1 to I exclusive. And we got to remember that I represents the new segment, which is why it's going to be exclusive, and we're not going to include it in the substring. And then we're going to add that to the results array list. And once we've iterated through the entire string and we've captured all of the given words, then we can return the results at the end. The time complexity of this program is going to be big O of n, where n is going to be the number of characters within string. And as the data may increase or decrease, such as the number of characters within string, the runtime of this program is going to stay linear to the amount of data that's within string.